get started. So in yesterday, the one I posted online was 2.1, which was average rate of change. That's stuff you've been doing since grade 9. When you calculate slope, you're calculating the average rate of change. Okay. There's even a section in grade 9 that actually says rate of change. So what's new this year, in this chapter, is going to be instantaneous rate of change. So it's not an average over a period or x of values over a set of domain, over a range of values. Sorry, the instantaneous is what's happening at a specific point. So we don't want to know what's happening over a period of time, we just want to know what's happening at that exact time, at the exact point. So that's when we say instantaneous. Where do I say that? So it's the exact rate of change at a specific value. Okay? So in my lesson I was saying yesterday, for average rate of change, to distinguish which one you have to do, because sometimes a question will just say, calculate the rate of change. And you're like, well, am I doing average or am I doing instantaneous? If they give you a range of values, like in yesterday's lesson, so I say, what's the rate of change from 3 to 5? If they give you more than 1 point or value, then that's average. Okay, so you're going from 1 point to another point. If they just give you one value, they say, what is the instantaneous, what do they say, what's the rate of change at 3? Then that's going to be instantaneous. Okay, distinguish between the two. In this section, obviously you're just doing instantaneous unless it tells you otherwise, but later in the chapter, sometimes it doesn't distinguish which one to do, so you have to look at what's given. Okay, multiple points is average, 1 point is instantaneous. Okay, so we call that point A. Okay, we'll talk about it. There is 3 methods to calculate instantaneous rate of change. 3. So we have preceding and following, we have centered, and we have difference quotients. Okay, so for each example today, I'm going to do each of the ones. Okay, some of them, you're probably going to like better than the other 2. Centered is probably the quickest one, but the most accurate one is going to be the difference quotient. Okay, on a test, I would probably specifically ask you to do one. So in this question, I'll say, calculate the instantaneous rate of change using the difference quotient or using the centered method. If it doesn't ask, you can use any 3 of the methods or the one that you prefer. Okay, same with the homework. Some homework questions will say, use this method. So these are the 3 methods here. But sometimes it won't ask you, so it's up to you which one you want to use. This one here, though, will be the most accurate one to use. Okay, number 1. Does anyone not have this first part? We're good? Okay, a basketball player attempts a 3-point shot. The table of values shows the ball's height above the ground at various times during its flight. Okay, estimate the instantaneous rate of change in the ball's height at exactly half a second. Okay, using the preceding and following. Okay, so now here it just gives you 1 point. Okay, so we want exactly at this value, so that's automatically instantaneous. Okay, even though it says it here and it tells you which one to use. Okay, so we're going to do the preceding first. Oops. And then we'll do the following. So this is going to be F at A minus H. just slipped my mind. Sorry, ignore that formula for now.
Good morning, Robert F. Hall. Today is Friday,